All right. Good afternoon, everybody. This is Raul with Anant. We are Cassandra Lunch. We've been doing Cassandra Lunch now for about 13 weeks. We just started recording it a few weeks ago, considering that there's a lot of things we talked about that could be useful for other people. I think it's good for people to be able to revisit these topics later on. Today, I am going to dive deep into a few open source projects that can help folks get a project started. And then, we always will cover some Q&A if anybody has any questions about whatever they're working on Cassandra-wise. Aku and I co-organized this meetup. If you or anybody would like to practice their communications, presentation, networking skills, we'd love to get some help. Basically, running a meetup is a volunteer job, and it's helped me in my career, and it can help anybody in their career if they take on some leadership responsibility for a meetup. So we are actually DC and Chicago together. We were running these meetups physically, but now with COVID, we're doing it virtually. Cassandra DC and Cassandra, specifically Cassandra DC, is part of the Data Community DC meetup community, which is inclusive and welcomes people from all backgrounds, and would like to get speakers from underrepresented communities to present on topics. We're part of a larger community, as you can see, Data Science DC, Women Data Scientists, Night Owls, Data Wranglers. So what do we talk about here? Generally we cover Cassandra, data stacks, Cassandra variants. We spoke about that last week, and the technologies that relate to Cassandra. Normally, we use this opportunity to get folks that we don't know to introduce themselves. I'm pretty sure everybody here is somebody who's been here before. Group rules: if you have a question, just ask it, be polite. It may be easier if you just put it in the chat window. And it's also an opportunity for you to add to the conversation. So if somebody's presenting, you can just say, oh, I also know about X. So today, as you can see, we're going to go over a bunch of open source projects that could be good starting points for others. So if you know of another one, we can definitely talk about that. DataStax is one of our sponsors. So is GW, and so are a few other folks in the community like Wavical and Eastern Valley. We have some institutional support. All right. Any announcements? Jobs, hackathons, meetups, conferences, classes? Anybody giving a presentation or a webinar coming up in this week or coming up next week that would like to just announce it real quick? And you can also share the link on the chat. Akwi, do we have anything coming up?
Not this next week, but soon.
Okay. Do we already have the link for it?
Nope, not yet.
Okay, got it. Great. No worries. So we have ongoing weekly lunch calls like this, but then also DataStax is doing a workshop series. After that workshop series is over, actually our second talk on the event-driven toolkit is coming up. The first one was how to quickly build an API on top of Astra, and then the second one is how to take that API and then make it event-driven using Kafka. So look forward to that event getting published and circulated. With that, we can go ahead and get started. Today, while I was thinking about, what we could talk about I often find myself answering questions with people that when they ask to say, okay, go take a look at this code that somebody else has written. It may be a good starting point. And in other databases, there is a lot of code and actually a lot of schemas for, let's say, MySQL application on every programming language. For Mongo, primarily probably in Node.js, or PostgreSQL and PHP. And so you name it, there's a lot of code out there already working with a data model, with the data access layer, sometimes even a front interface layer. So I thought about what applications are useful that I've seen in the past couple of years, and I would like to just go through and show it to you. And it's not that it's a recommendation or an endorsement of the actual application, because some of these applications are old, and meaning that the people stopped committing to them a couple of years ago. But it doesn't necessarily make them useless artifacts. Some of them are really good references to take a look at and learn something from, because, why reinvent the wheel? If somebody's done the work, we can take a look at it and use it. So in no particular order, I've got about 10 different projects. So I'm going to spend about a minute or two on each so we can get through it, and I don't want to keep you guys too long. And I know that some folks have some questions on related to Cassandra that we can come back to. So one of the most interesting open source projects that I've seen recently is a full-blown multi-tenant software as a service boilerplate for a universal web application with React, Material UI, Relay, using GraphQL, JavaScript Web Tokens, Node.js on top of a Cassandra database, but also tested on Cassandra, Alessandra, and Scala. So if you remember I think last week we talked about the different variants of Cassandra. Well, this one they've already tested it on those different variants of Cassandra. And, it's a complete application, meaning there's a database server, there's a kind of a web server or an API that talks to it, and then there's a client that's written in React that's talking to this via GraphQL queries. And if you're familiar with front-end engineering, this is no easy feat to make a React application use GraphQL, and also React Helmet, for example. This makes it, SEO friendly. I mean, it's quite a feat. So I have not cloned this project and used it, but just looking at the application, it follows a lot of the same conventions I've seen on other boilerplate applications, meaning it gives you everything. There's a let's see, I thought I saw the CQL statements earlier, but it gives you pretty much everything you need to get a simple application up and running. Okay. And then there are a couple of different revisions to it, so take a look and make sure that you're looking at the right revision. All right, so this is one. Oh wow, this revision has a live okay, no, it's not working. I thought that there was a live demo. Another one that I see is it's a little old. It doesn't have as many commits, but it's a event-sourced CQRS based architecture application using Kafka, using Cassandra, and it's got an API layer to it. So the shopping cart is built using event sourcing. So what would I look for when I'm looking at this? I'm looking at, for example, the table structure. They have built a shopping cart on top of Cassandra. I want to take a look at how did they do that. So they have some, not only do they have some object tables, they have some report tables. So their data model is actually pretty good. They're doing the query-driven design methodology here. So, okay, worth a look. I would say definitely the data model well as the general pattern of how do we make an event-sourced system. Oh, and I forgot to mention that they're doing this whole thing in Scala and Akka, which is one of my favorite platforms to program in general is Akka and Play. I don't know if they're using Play, but it's worth a look. Okay, so that's number 2. And as I said, this is in no particular order. I'm not doing like a top 10 or anything. This one I found today. It's called the Bandgap Backend. And Bandgap is basically a set of applications that are like template applications. So here's a template application that looks and feels like WhatsApp. Or here's a template application that looks and feels like Instagram. And they not only have the front-end applications, they have all of the different back-end systems that you would need to run an Instagram. Okay? But it's all powered by this Boss backend. So what is the Boss backend? Boss backend is based on top of Cassandra using Play, Akka, and DataStax drivers. They have different systems in there. So one of the biggest systems they have is a backend generator. So you design the data model in JSON, it will then generate 90% of the code for service, and then several utility functions. They have the security frameworks using let's say Google Auth 2, Open Up 2, networks. To be able to use Twilio to send text messages or Mailgun to send email. They have a lot of different ways to do that. They have push notifications, geoservices, geocoding all built in, dispatchers, workers, basically applications that need to be doing things on behalf of the application. Because they're using Akka, it's like a cluster of these things kind of running, right? So yeah, it's quite a set of code. I mean, it's not something that you can just open and run and expect to understand in one sitting. But if you really want to see how a very large-scale application can run on Cassandra using Akka, Scala, Play, it's worth investigation. Right, so this is kind of the general workflow. You make a JSON config. It creates the CQL. It creates the Java client. It creates the API and the client APIs and all of the utilities around it. So very impressed. And by the way, they have videos for each of these. So it's not like you're just left out and you got to figure everything out. All right. Number 4. My Moments is another Instagram clone. There's an article that is associated with it. But as you can see, it's a full-fledged application. They use Kafka. They use Cassandra for the feed. They use Elasticsearch for the search. They use Neo4j for the graph. They have Spring and Spring Data basically being used for the API layer. They have a React and I forget what this is. I think it's not Vue. It's another type of front-end framework. There's so many these days. And it's all based on Docker, and it can be basically deployed to Kubernetes. I think that's probably a requirement. I think they're still outside of Kubernetes. I think right now they're just on Docker. And then they have built-in logging and monitoring and whatnot. So it's worth a look. This is kind of a screenshot of the application working. It actually looks like an Instagram clone. Why would I look at this? I'm just curious. How did they do this application with Spring? What are the conventions that they used? How did they construct their whole code base to have everything here, including the logging and the Zipkin tracing, which is distributed tracing, right? So very full-fledged. There's a couple of screenshots, right? This is a profile view. This is, I guess, one particular photo view, right? And even if you're not making like a social network, if you're making any scalable application, this would be worth a look because it has everything: front-end, API, data layer, Kafka for event-driven. All right, number 5. This project has been, I guess, retired because the company that was making it retired it. I would not say you should use this code because nobody's maintaining it. But what I found interesting in here is that they claimed to make one framework that you could deploy to EC2 Container Service, Docker Swarm, Mesos, or Kubernetes. It would bring up all of these different services if you needed them. Kafka, Cassandra, Mongo, Redis, Couch, et cetera, et cetera, et cetera. So it's just worth a look to see somebody's work as a piece of art to say, what can I learn from this? And there's also some things I would say what I don't want to learn from them is that you don't need to reinvent the wheel. Somebody else was probably doing a serverless platform with stateless services that is still surviving. But yeah, it's got some good code. I looked at it in terms of orchestration and architecture. And it's not necessarily a Cassandra application. It's more like an infrastructure that has serverless functions on top of Cassandra. This, number 6, is not a complete front-end all the way to back-end application, but it is an example of Kafka, Cassandra, Elasticsearch with Spark structured streaming, right? It starts off with just getting Cassandra up and running, getting Spark up and running, and essentially as you put stuff into the Kafka queue, you're able to read stuff off the Kafka queue. You can even see the data going simultaneously to Elasticsearch, and then you can search it on Kibana to see how it's happening. So if you want to learn about real-time engaging with Cassandra, Spark, Kafka, Elasticsearch, this is a really good code base to just pick it up and start playing with it. By the way, all of these links are in the Cassandra.Link knowledge base, and if it's not there this afternoon, it will be there by tomorrow morning because we regenerate the website. But at the end of this call, I'm going to save these links and I'm going to give it to one of our team members, and we'll have a blog post with all these links as well, so you don't necessarily have to write everything down. There will be a blog post with all the links. All right, number 7, REST-Base. REST-Base is one of my favorite projects. It is probably one of the largest deployed applications on top of Cassandra. What is REST-Base? REST-Base provides a low latency, high throughput API for Wikipedia, Wikimedia content. It's a storage proxy. So we all know that MediaWiki, which is the open source software that runs Wikipedia, is created on PHP. PHP, I would say some bad things about it. I'm not really a big fan. I mean, even Facebook uses PHP, but they had to reinvent PHP into something called Hack, which takes PHP and basically makes it into like a just-in-time compiled language. But in order to scale an application like Wikipedia, you have to have some sort of cache. So every API that Wikipedia uses to render content is then fronted by REST-Base. So when you're looking at Wikipedia, all the API calls are actually hitting REST-Base. And if that call needs to be refreshed, REST-Base calls the actual API behind the scenes, gets the data, and stores it in REST-Base. So REST-Base is like an API gateway / cache. Okay? The storage API is similar to DynamoDB or Google Data Store. So if we take a look at the markdown here, this is the design. To show you this. Right, so I'll kind of zoom in here. So Wikipedia has the following applications. It has MediaWiki, Parsoid, I don't know what else you just answered. A mathoid is basically used to, oh, I know what they're used to take markdown that's, or whatever the wiki markup is, and actually it renders it. It renders it into HTML, and there's auth service. So all of those interactions that you are making with Wikipedia goes through REST-based. So these are mapped to the back end, and when it gets the data, it stores it into Cassandra and retrieves it from Cassandra. That's the reason why it's able to scale for millions of users all the time. And technically, you could use it to write to another database, but you know, who wants to do that? REST-based, you know, really well-scaled, well-proven application that Wikipedia uses right now. Okay. Also, when you access Wikipedia APIs as an end user or end developer, you're also hitting REST-based. Okay, that's what you're using. You're actually accessing REST-based when you access Wikipedia APIs. Right here. Right? This is hitting REST-based right now. All of these different feeds are coming from REST-based, powered by the APIs behind it. Number 8. This is the Django Cassandra Engine. Django is a popular web-based framework for Python. Django is, I would say, heavy in comparison to Flask, because Django doesn't just make an API, it's also, there's a front end. There's an actual admin tab. So this Cassandra Django engine allows you to make a data model, and that data model will get created as a Cassandra data model, and it automatically will give you admin panels to edit and update the data, and you can also have a front end, right? So commonly when we make an application, you have to make a database, you have to make an API, you have to make an admin panel, and then you have to have whatever application you're going to be using to access it. This is a great way to get started very quickly if you want to make a quick application on top of Cassandra using Python. Okay. So yeah, you have to define a model using Python, and then it basically synchronizes the model with Cassandra. Okay. Pretty useful. Number 9. This is technically not an application starter, but I wanted to bring this in because this application is a web-based SQL editor that can talk to many, many different databases. In fact, it's kind of similar to Redash or Metabase, but what I like about it is that it's super simple. So if you're starting to run Cassandra applications and you want to quickly see the data in there, and you don't need like a BI tool like Redash or Metabase, this would be pretty useful to just stand up in a Docker container and talk to your Cassandra database to see what's there, right? From a very basic, dev admin type of, needs, it's very useful. And not to mention, you can see how they made it. So this application is written in JSON. Actually with Node.js using TypeScript. TypeScript is a fairly popular Node variant being used in the enterprise. So if you want to learn TypeScript, this would be a good starting point. They already have Docker containers. So check it out. And then finally, number 10, again, I said I was not doing it in any particular order, but Jhipster is actually a very popular framework used to jumpstart applications. And what is Jhipster? So Jhipster essentially is a generator where it generates the landing page for the application. It generates the monitoring screen for your application. It has generated the user forms, or whatever data models you create, it will generate that. You can change what you want to log or not log. You don't have to go and change settings. You can just go here and say, I want to do trace on this class, and I want to do warning on this class. but it does a whole CRUD application with a front end using Angular, and I believe also with the React. Okay. But the thing is that, oh yeah, with the React overview, the thing that's really interesting about this is that even though it does all of this for you, it's not tied to one particular database. So you can use it to, you can use it with Cassandra, you can use it with Mongo or Couchbase. If you want to have search, you can use Elasticsearch, and it will basically take care of saving your data in Cassandra and indexing it in Elasticsearch. If you want to use the top subsystem, you can elect to use Kafka. So it's just kind of a starter kit that if you want to build something and you don't want to do all of this work, you can get this started. And what is this in comparison to other applications that I showed you? The feature that I would say the big pro for this is that they have good documentation. They really have good documentation explaining every step of the way. How do you create relationships between, objects? How do you create a Spring service? So if you've never used Spring, it'll get you, up to speed. They also have a pattern for using, API gateways internal to the application using Trafic, which is a proxy. So if you don't know how to make distributed applications, if you don't know how to use microservices, if you don't know how to connect the top, the front end to the back end to the database, and you want to make an application pretty quickly, this is a pretty good starting point. And they have so many modules. They have some of these are new. I don't even know about this, but like you can run it on .NET Core. You can have Google Maps, and this is not the full list, but you guys can explore all the things you can do here. Let's say, and here's another fun feature. If you use Eclipse, there's a Jhipster IDE that makes the process of using Jhipster even faster. So you say, I want a Jhipster project, you create an app, right? And bam, you have your full application ready to go. Kind of fun watching this. I didn't see this before. They also have Visual Studio Code and Atom. So those are 10 applications that you can use today to get started with Cassandra. Any questions about any of these? And then we can open it up for just general Cassandra questions.
I had a question. So would you say most of these, like sometimes when I'm thinking about using a starter, I would be kind of scared of just getting locked in or just get bogged down by the decision choices they made. Would you say mostly this is just for learning, maybe like a personal project, or would you actually use one of these in production?
This one, Jhipster, I would use in production. Because it's been used in production, and there are so many contributors to it. There's so many plugins for it that at this point it's no longer locked in the sense that if the people that are maintaining it, they stop, there's enough people outside of the community that's going to give you what you need. They even have a conference. I mean, it's kind of a big deal, right? So this one I would say. The SQL pad is more of a tool, so I'm not going to talk about that one. Django, Cassandra Engine. I mean, if you bought into Django, and you want to make a Cassandra app, you kind of would want to use this. Otherwise, you're just starting from scratch. There's just a lot of work involved. REST-based it's more of a tool, but REST-based is used in production. The other ones are kind of reference. I would say like FireCamp is reference, structured streaming examples of reference. My Moments, yeah, probably reference because they're just showing you how they did it, so it's not really generating anything. Bandgap, I'm on the edge on because it generates code. It seems like it's doing a lot of really cool stuff. I'm not really sure if I can buy into this because there aren't that many users behind it. And this one is kind of, again, more along the lines of, as a boilerplate, they're gaining maturity, but they're not that mature yet. All right, any other questions, or do you have a follow-up to that, Ryan?
No, that was just a question.
Cool. TK or Arpin, are there any other applications that are really useful to get started with?
If you want to learn how to use Cassandra in the cloud, you can use our Cassandra.API repo, and it has a full stack front end, back end, and Cassandra's in the cloud using DataStax Astra. Front end is built with React and Material UI. We have two backends, so if you're more familiar with Node, you can use the Node backend. If you want to use Python, we have a Python API as well. And then again, like our Cassandra service is in the cloud, and we use DataStax Astra's drivers to connect to it and do the functionality on that.
Cool. Yeah, this is a shameless plug, but I mean, this particular application is actually running on Astra, but it can be used with any Apache Cassandra with some minimal changes. So as an objective party taking a look at this, I would say that my main inclination to use this is that it's very simple. It's very understandable. The code here is clear that if I go to the Node version or the Python version, right, this whole API is right here. It's in one file. And, well, that's for processing. But all of the API calls, I can understand what's happening. I can see that it's making a CQL call here, right? So it's just easy to understand. So not so much that I will use this and continue using all of the conventions, but to start off as let's get started with the basic endpoints that I would need in an API. I think I would go ahead and copy and paste and change this around. So yeah, good. Thanks for bringing that up, Arpin. All right. Any other questions related to this? Okay. So Ryan had mentioned he had a question related to Yugabyte Inconsistency. Do you want to send that link on here, and I'll bring it up, and we can quickly take a look at it?
Yeah, let me just grab it. It's Yugabyte's critique of Cassandra. I'm sure they talk about themselves some too, but I posted the link in the Zoom chat just now. Yeah, so I was just wondering what everyone's thoughts were regarding their critique, if it was fair or not. They're basically just saying, well, Cassandra is, obviously there's not totally consistent. It's eventually consistent, but they're just saying, well, it's not consistent enough. Yeah, like this is the diagram, like want transactional behavior, get ready for dirty data or poor performance, right? So I was just wondering what you thought about that idea, if there are workarounds, or if it's kind of like what Yugabyte's saying is, no matter what you do, it's just not built for that, so you're not going to have a good workaround.
Yep, absolutely. I know I'm familiar with Gigabyte. I'm familiar with the other variants, and their critique is valid. The other side of what they claim is for them is that Gigabyte solves all these problems, right? Then it's transactional, and what they're talking about, that it's not consistent enough. These type of challenges, I'll walk through, how they're in the real world, how we manage those. But the way that Yugabyte does consistency is that there's a lot of kind of like engineering that they do where it's no longer a truly master system, right? So first of all, Yugabyte is a fairly new technology, and I'd like to kind of learn a little bit more about how big it's been, what's the biggest cluster that's powered by Gigabyte. But the way that they're able to do consistency is that they use a wrapped group, and for every, they call it a tablet, for every, I'll even bring it up. So just to kind of give you guys a scenario, Yugabyte's a good product. I'm not critiquing the product. They basically give you PostgreSQL, Redis, and Cassandra compliant APIs on top of a very scalable cloud native architecture. And what happens is that they need to have a master, and then they need to have different tablet servers. Without master servers and tablet servers, it doesn't scale. So they're able to do consistency in a similar way to, let's say, how Hadoop has name nodes, where they have a wrapped consensus centrally that is managing the wrapped consensus of specific tablets. So in Cassandra, the consensus is on a partition. What they do is they do consensus on tablets or sets of partitions. And again, I'm pretty sure that it's consistent. I just don't know. I have not yet seen it to be in real life in a very, very large scale scenario. Okay, so let's go back to their main kind of knocks on their issue is that in order to get high consistency in Cassandra, you have to have very, very high latency. So that can be done with using something called lightweight transactions, right? And that's true. Lightweight transactions are heavy. The other way to do it is what they're talking about is, like you have to say consistency all, right? You have to give it a very high consistency in order to be able to get that. That has a latency as well. There is somewhere in between. And the somewhere in between is you write quorum and you read with quorum. Generally, I shouldn't say generally, pretty much all the time, it's going to give you a consistent answer. And another way to kind of keep things consistent is that whenever you do a write, asynchronously, you can do a read and let Cassandra or whatever the driver will asynchronously do a repair. Every time you do a consistency all read, that's doing a read repair. Okay, so what you're bringing up here is very accurate. That there are latencies. The way to deal with these latencies is not always with lightweight transactions. There are ways to get low latency consistency by doing what I just mentioned, right? You write with a lower consistency level, but then you asynchronously do a read. So then finally the question comes is, when I want consistency, what do I want consistency for? So let's say in banking or e-commerce, it's always like, if I take this out of the queue and I start putting it into, if I take it off of the shelf and I start putting it into the shipment queue, then technically that thing is no longer available in the inventory. So somebody else should not be able to buy that product. Or if I'm about to buy the product, maybe just take it off to the quote digital inventory at that particular moment, right? So in these scenarios, the consistency requirements that we're talking about are very high. Like we have to have a very legitimate inventory, otherwise people will be buying something that doesn't exist. So the way people do it in the Cassandra world is using a two-phase commit, essentially. And the two-phase commit is used in other databases as well, but it introduces a latency. Now, if Yugabyte has solved that problem and it scales, that's great. But ultimately, we're talking about what is a proven technology that's used by very, very, very large companies. What widespread support versus something that is relatively new. Now, both Yugabyte and Cassandra are open source technologies. Both of them have a lot that they can learn from each other. I don't see Cassandra moving from Paxos to Raft anytime soon. Okay? So what do we do here? I would say if you're using Cassandra, use Cassandra unless you hit a very, very specific consistency need, and you can either use Yugabyte or a lot of times you can just use another relational database. If you need ACID transaction, you don't always have to do a distributed database for that. There's plenty of scenarios where you have a massive NoSQL database, but for the actual transactions, you use a relational database. But the history of the transactions is stored in Cassandra. The inventory is stored in Cassandra, but the actual act of the transaction is all being done in relational. So I'm giving you a fairly political answer here, but in terms of technically speaking, they're correct. All of the things that they're talking about is correct. Do you want to have a follow-up question to that?
Yeah, so just to summarize, you're saying they're correct. This is a big problem, and you do have to find a workaround. It's just that maybe Yugabyte doesn't have this, like, they're not going to be able to solve it totally either. There's still issues with their solution as well, more or less.
Well, I wouldn't say that there are issues with their solution. It's just their architecture is not a. So the biggest thing that I have as a issue is that they're not a completely master system. They have a master and a tablet server. So it's this. This process of it is what makes me a little bit uneasy. And the other is that their data is being. Well, you can go into the architecture. It's a pretty good architecture. That's the only thing I have against it. Now, this is new for me, where it says that it's an optional thing. But I'm pretty sure that they have to have the master servers to ensure that ACID-like consistency. There's another project which is, here we go. This is what I wanted to think about. Yeah. So ScalarDB is a ACID compliant API on top of a non-ACID database. Specifically, they do it on top of Cassandra. And it's actually based on another technology under the hood called ScalarDL. And ScalarDL is a tamper evident scalable distributed ledger. So it's not blockchain, but it's a distributed ledger. And I think it's here. I was going to show how they do it. But the way they do it is they use lightweight transactions by verifying that, before I write my next ledger entry, I need to make sure that I had the latest ledger entry to verify that I'm writing the next thing. Otherwise, you have to go to the end of the line, essentially. But ScalarDB uses some of those concepts from ScalarDL to create a scalable, ACID-compliant database. And this paper, here we go. This is from last year. This paper talks about how they do it. So before they write data, they have to verify that each entry is supposed to be the next thing after that. And here we go. Two-phase commit. Right? You prepare it, but right before you write it, you have to verify that. And then you can commit completely. Okay? All right. Any other follow-ups with this?
Yeah. So just if you were to make an off the bat recommendation, someone says, "Hey, I want to build a e-commerce site, and I need that kind of ACID reliability, but it's big and it needs to be able to scale, and I want to use Cassandra." Your recommendation would be like, what would you say you say you use two-phase commits or just count on latency, or what would you do for that?
So even at sites like Amazon, okay, at that scale, even at that scale, the transactional nature of like having a lock, all right, it creates latency. This is why SQL Server, Postgres, Oracle cannot power Amazon. You just can't do Amazon on a completely locked-based system. So you have to have small locks everywhere else, okay? So that's what Gigabyte is proposing. And if the question is, I want to make a very scalable e-commerce site, more than likely I'll say, why? Just use Amazon. Just go sell your crap there. No, I'm just kidding. It really just comes down to, what do you need for the user? Okay? Many times in inventory management, like between the time the person looks at something and they're done kind of like about to sell it, right? There's a way to just put that product in a particular, let's say, shelf to say this thing is no longer available because this person is about to buy it. And that's good enough. And you can have millions of people buying and checking out without any conflict, right? So I don't really see the need for e-commerce ruling out, basically available soft state, eventually consistent, base versus ACID. I don't necessarily see it as ruling it out, because I've worked in very, very large e-commerce platforms that are for very, very big retailers, and they use Cassandra or they use DataStax or whatever. And when this thing comes up, so my first question is, well, why did you go from Oracle to Cassandra in the first place? Like, well, it doesn't scale. Okay, it doesn't scale, all right? So what is it that you need to scale? Well, we need the inventory to scale, meaning people should be able to read the inventory. We need the data, when it's updated, to be distributed, and that needs to scale. Okay, great. So what part of it can basically not scale? And the not scale part of it is the math about this is the inventory number. So what they can do is they can create a queue that basically takes charge of the inventory, and all updates to the inventory are being done through a queue. Okay, and until that queue is processed, essentially the person can't buy the item because the inventory is not consistent. So you either do that, or you just use consistency all, and you wait for the update. So we're talking about, like, in ACID world, we're talking like less than 10 milliseconds or 5 milliseconds or even less to like 50 milliseconds or maybe 100 milliseconds. And when you're comparing 10 milliseconds to 100 milliseconds for millions of transactions, the users really don't care, and they really are not affected. Because if that were the case, then Uber would have to run on Oracle and not Cassandra. Right? If that were the case, then Grubhub would have to use, which is now part of Uber, but they would have to use Oracle and not Cassandra. So these are e-commerce platforms. There's transactions happening. People are getting orders, right? So it's been proven over and over again that you don't have to have ACID to do e-commerce. If you're trying to sell me on the fact that I have to do ACID for e-commerce, we're living in a different century these days. That used to be the case like 20 years ago, but it's no longer the case these days. All right.
Okay, just sorry. And the last thing, I kind of got started looking into it more because I was listening to a podcast about Kafka, and they were talking about using Kafka on top of Cassandra. And so I was thinking, oh, why would you need to do that? And so that's maybe the solution is use Kafka as a queue on top of Cassandra, and then that will help you keep things organized. I see.
Yeah, and actually, Kafka is used for many, many reasons, but one of them is also as a ledger. So like Hyperledger is an open source, ledger framework. Part of it can run on Ethereum, but it's slow because Ethereum takes time to get consensus, even with their new architecture. But with Hyperledger, they have one called, there's so many different Hyperledgers now. It is Fabric. Forget the name, there's so many Hyperledger, Kafka. Yes, it's Fabric. I was right earlier. Yeah. So basically, Kafka is used as the consensus engine for Hyperledger Fabric. And essentially, you interact with Hyperledger. Hyperledger writes data to Kafka, but before it's committed, all of the members of the Hyperledger trustless system have to basically confirm, and that confirmation is done through Kafka. Okay. This is a very fascinating project.
Okay.
Yeah, go ahead.
Okay, last thing. So then does adding Kafka on top, does that decrease availability? Like, is it more likely that a customer will click, purchase or check out or whatever, and it just doesn't go through because you're adding something in the middle?
No, if anything, adding Kafka will scale the system even more. Because the act of committing to buying something and the act of updating the inventory, they're decoupled. Okay? And essentially, like, in this case, okay, you see this thing, in ledgers in general, there's a process called like ordering to make sure that this thing is in the right order. So before you put it in the Kafka queue, you verify that. Oh, I have a token to put into the queue. So as long as you do that verification process to say I'm in the right place, then this thing can scale infinitely. Okay. Yeah, and actually the ScalarDB also does the same thing. They have a process called the orderer, which essentially double checks where to put it. No, it may not be here. Yeah, it's the same thing. In this case, they're doing the same thing. They specifically make sure, using consistent hashing, that what they're about to do is the right step. And that is what makes it consistent. All right. I'm sorry, I'm talking about it in like high, broad generalities because we're coming to the top of the hour, but these are like really deep topics in scalable systems where people are trying to solve this problem, and more power to Yugabyte. I love the fact that they're trying to solve that problem, and it's a great product. I mean, honestly, I think that either Skilla or DataStax should just buy that company and take their technology and put it into their tech. It's a very fascinating company. All right. Cool.
What's your opinion about distributed ACID compliant databases such as like MarkLogic or ArangoDB, such databases?
No, that's a good question, and there's other ones too, right? There's CockroachDB. And by the way, Cosmos, and there's also Google has one.
Spanner?
Spanner, yeah, that's exactly what I was looking for, Spanner. Right. So for Spanner, that's the one. Spanner and Cosmos are probably the two that can actually meet the need, but they have special hardware to do that. They have very specialized clock hardware to make sure that it is consistent, right? And still, there's a little bit of a latency. So when we're talking about scale, okay, when we want to do 75,000 machines and have a general consistency, that's the point where I don't know if the speeds are equivalent, because Cockroach and Arango are built for a different purpose versus Cassandra is purely based for speed on the read side. Read and write, that's all it's based for. It wasn't really created for the kind of the logging perspective. You see what I'm saying? Like, it's not designed for that. It really wasn't meant for that at all. And maybe they'll get there in the future. So if you're looking for, let's say, multi-model, there's Couch database, there's Arango database. They may be perfect for that use case. And, you know, Arango also has graph. I mean, it's got a lot of stuff on there. So why would you still use DataStax? Well, DataStax has, you know, CQL, which is like SQL, versus Spanner or, let's say, CockroachDB. CockroachDB is Postgres SQL compliant. There's another one called TiDB. TiDB is like CockroachDB, but it's MySQL compliant. Okay? And all of these databases, they have somewhat of a drawback that eventually, when you get to like the global scale, it's not really optimized for both high-speed read and high-speed write. They're optimizing distributed SQL, the ability to do joins, the ability to do locks, and things like that, right? They're not optimizing for read and write. So in a robust architecture, you might end up having both. You may have something like Cassandra, and you may have something like CockroachDB or ArangoDB. Doesn't mean that you have to put everything on one database. That's what I'm trying to get at. Like, if you really need something, do another database. But Cassandra's for like high-speed write, high-speed read, multi-region replication, right? Those type of things are where it really excels. Good question, Nassim. Any other questions? Actually, we're right about out of time today, but this will be recorded and put on YouTube shortly with a synopsis. The other links that we found today, I will also have that as a separate section in the same blog post. But the top 10, or not top 10, the 10 things that we looked at are also going to get featured. Okay? All right, guys. I want to respect your time. It's 1 o'clock. Have a wonderful rest of the day. And same time, same place next week. We're talking about Cassandra. If you guys have anything that you want to talk about, do a demo, do a presentation. Love to have you talk about something. All right? See you guys. Take care.
Thank you.